Thank you. I, too, am happy to be participating in today's event. I can't imagine anybody is more indebted to Finus than those of us who were his students and often simultaneously his low-wage employees. I was both of those things back in the day, and I've always been grateful to Finus for the training he provided as well as for his friendship. And given that a lot of my former Welch Unicon taskmasters are here today, I can perhaps admit that all the hours I toiled for the corporate empire probably helped whip me into shape. It's been already said today that Finus taught us all to take the data seriously, and I would like to think that I learned that lesson. I'm actually obsessive enough to have written this replication study that I'm going to talk about today, and it's not something I would typically present. Not everybody has the stomach for this kind of replication work, but I actually thought that it's perhaps a appropriate homage to Finus, because this is a paper that's certainly all about the data and all about trying to get it right. So here we go. In terms of the big picture, a number of studies have asked whether evidence of employer learning depends on the type of worker or the type of job, and a key paper here is by Arcidiacono, Bayer, and Hismo, ABH. In this paper, they show evidence that there's learning for what they call high school grads. It's the guys with 12 years of schooling. They show no evidence for the S=16 guys. And this suggests that there's something about the college education or about the people who go to college that makes people able somehow to signal their productivity to employers at the outset of their career. This evidence was consistent with something shown much earlier by Bauer and Haskin-Deneau. These guys showed evidence of learning for blue-collar workers, but not for the white-collar workers. In a paper by Hani Mansour, he showed that the evidence of learning is tied to the long wage dispersion within occupations. And his argument was that the more uncertainty there is to resolve in an occupation, the more learning we're going to see. And in an earlier paper with my co-author Andrew McGee, who was a student of mine, we were asking whether the learning depends on the type of skill and its importance to the work that's being performed. So the idea would be, if you're hiring an accountant, you'd better learn very quickly whether he or she can perform numerical calculations. If you're hiring a dancer, that skill is just irrelevant, so there's no need to learn about it. And in the process of carrying out that paper, we were revisiting all of these other findings, and we couldn't come close to replicating the ABH findings, so we eventually decided to attempt a systematic replication analysis. We and they are using NLSY 79 data, and in contrast to what they find, we are seeing comparable evidence of employer learning for both schooling types. In the paper, we're attributing the discrepancy to differences in the way that we define the career start date, by which I mean it's T=0. It's where you start the clock on your measure of cumulative labor market experience. ABH start the clock the first time they see a respondent show up at an interview non-enrolled in school, and it's independent of whether that non-enrollment spell is very short. It could just be a summer vacation. It's independent of how far the person might be from what we would typically consider the true completion of schooling. We define T=0 as the first time he starts a non-enrollment spell that lasts at least a year, so we're looking at a somewhat more permanent definition of school exit. There are plenty of cases where the two dates agree, but when they don't, the ABH date almost always precedes ours, and the discrepancies are highly concentrated among the more highly schooled workers. So the longer you stay in school, the more likely you are to have a short-term enrollment break, and certainly the more likely you are to be observed during one of those breaks. Because ABH are systematically starting the clock too early for the highly schooled guys, they're systematically overstating potential experience, elapsed time since that start date. And we believe that that's causing them to understate the learning effect for that highly schooled sample. This question, when does the career begin, would be irrelevant if life were this simple, if we all just went to school and stayed in school and didn't interrupt our schooling, didn't work while in school, and then made a nice, clean transition to employment. Don't go back to school, work continuously.
Could you explain what, are you going to explain what the employer learning test is looking at?
Indeed.
Or so you're going to do it after you do the data?
Next slide, I believe.
Okay. All right, cool.
The model, yeah.
Because I'm kind of in the dark.
Yeah, we know your results, but we don't know what you refer to.
We'll get there in just a moment.
This isn't the first time she told me to shut up for you.
Did I say that?
Very nice about it, actually.
If life were this simple, and most theoretical models assume it is, t equals 0 would be uniquely defined. The data would just point us right to it, and there wouldn't be an issue. But when you look at longitudinal data like the NLSY 79 and other data sources, you see that an awful lot of people interrupt their schooling. A lot of people work while in school, especially the college goers, and young workers are certainly not continuously employed when not in school. And so because of these phenomena, whether you find them interesting or not, t equals 0 is not well defined, and as a user of longitudinal data, you really have no choice but to go figure out how to define it in a way that suits your purposes. And then even when individuals do make a nice clean transition from school to work, it's just a fact that the NLS interviewed a lot of people during the summer, during the school leaving era, which was more or less through the late 90s. Over 40% of the interviews were conducted in the summer. So if you're just looking for a point in time non-enrollment status, it's easy to find it in these data. So again, for all of these reasons, like it or not, as a user of these kinds of data, you have to figure out how to define the career start date. And I should note that we did this replication study not because we enjoy poking holes in other people's findings, but because in our mind, ABH have handed us just a very interesting example of when and why these kinds of measurement issues matter. The model. I just want to zip through it pretty quickly to show what the test is and to show the extent to which this model would actually guide us in addressing some of these measurement issues. So it's the employer learning model that originated with Farber and Gibbons. Workers enter the labor market at t equals 0, and this is where the learning is assumed to begin. At that point, their true log productivity can't be fully observed by employers. We're just decomposing it into its component parts. And so S, something like schooling attainment, would be the stuff that employers were able to observe at t equals 0, and we can also measure that. Q is something employers observed at t equals 0. We would not have measures for that. Z would be something like a test score that would have prevailed at t equals 0. Employers didn't have access to that information, but we do. And then the remaining unobservables. So employers are going to use the signals that they get, S and Q, to form expectations of the missing components. And that gives them their priors on that initial log productivity. And then from t equals 0 onward, they're going to observe these time-varying performance signals and use that information to update their expectations of what that initial productivity was. So this is the sense in which they learn. At every point in time, the employers are assumed to set log wages equal to expected log productivity. So the wages are going to depend on those initial productivity signals. Learning, which I'm just referring to as G for shorthand, And then I'm sweeping everything else into the residual because it's assumed to be outside of this learning process. So key assumptions, all the information is public, the learning is symmetric, so we only have to worry about how long workers have been in the labor market and not how long they've been with particular employers. That initial productivity is assumed to be independent of any subsequent skill acquisition. And the employers are only learning about initial productivity, so they get this new information and they're only using it to finally get right what that correct intercept for the log wage path should have been. So that was the employer's story, and then we would take the information at our disposal and use it to estimate what is a misspecified version of the log wage model that employers use. And we can derive the expected values of these parameter estimates. For the most part, we're looking at variances and covariances among those initial t = 0 factors, S, Q, and Z. The only thing in here that's time varying is the covariance between Z and G. It's the covariance between what the employers learn and our test score, which is a sort of speaking to the true productivity that they're trying to learn. And we can sign these time varying components so we get the prediction that over time, S is going to be increasingly less tied to log wages, and Z, our test score, will be increasingly tied to log wages. And that is what gives us the test. We're now going to take both Z and S, interact them with elapsed time, add those to the model. ABH are working with schooling-specific subsamples, so the S terms drop out, and then the key prediction for our purpose is that this parameter estimate for the ZX interaction is expected to be positive. So the model is actually giving us some pretty good guidance in how to think about the measurement issues. T = 0 should correspond to the point when the learning begins. X should just be the elapsed time since then. It should be the period over which learning takes place. We're looking for that positive estimated interaction term, and again, we expect it to be positive because it's driven by the notion that employer learning covaries positively with our test score. If we're overstating elapsed time, if we're looking at intervals of time when no learning takes place, that covariance is kind of pushed towards 0, and our estimated parameter estimate should follow suit. And I do believe X should measure elapsed time as opposed to something like time actually spent working, because that kind of measure would be informative about changes in productivity which are outside the model. And then finally, our S should correspond to what the employers would have seen at T = 0. This should be a time constant measure. The only new information that employers are getting would be the performance signals. So with these sort of guidelines for how to think about measurement, we can compare how we are putting together the data relative to what ABH do. We have their exact data, and we're making a parallel data set where we're doing exactly what they do when possible and just deviating when we think that it's important to do so. So in terms of choosing the individual respondents who should get into the sample, we're just going along with their selection rules. They require that valid AFQT score because that would be the measure of Z. The first point of departure is in the definition of the career start date, so the ABH start year is defined by them by going chronologically across NLS interviews. The first time a respondent shows up at the interview saying, I'm not currently enrolled or attending school, the follow-up question is, when were you last enrolled? And they're using the reported year as their start year. They discard the month that's reported along with it. We have our Light-McGee start date, which is the month and year that begins the first long-term non-enrollment spell, and we're using all available information on enrollment activities, including a monthly enrollment timeline, so I think we have a pretty good measure of that transition. Then in terms of choosing which wage observations to keep for the individuals who make it into their sample, we just go along with all of their selection rules. They require that a wage be reported in an interview year that is later than their career start year. We require the wage be reported at an interview month year that's later than our career starting month year. But we also require that it precede any re-enrollment spell that would lead to an increment in S, this business of going back to school and having your highest grade completed increment and having employers see that is just so outside the model that we're terminating the observation window when that kind of behavior is observed. Although with our start date, it's not seen very much. It's seen much more with their start date. Potential experience, it's just elapsed time since the start date, and they cut things off at the 13-year mark. Because they're aggregating all their dates to the year, their experience variable takes on integer values. We're measuring experience more finely than they are. Schooling, their S is the highest grade completed at each interview where a wage is reported, so it's very much time varying. Ours is the highest grade completed that prevails at the start date, so it's fixed. And then actual experience, in their article, they're not reporting any estimates based on actual experience, and I've suggested it's a bad idea to do so, but just as an idle exercise, it stands to reason that if instead of measuring elapsed time since the career start date, we measure time actually spent working, we can mitigate the effects of having too early a start date. And so just to see how this goes, we want to take their observations and ours and attach a similar actual experience measure to all observations. And to do that, in working with their data, we have to help them along and bring back the starting month that they had discarded. We're dropping all observations if the start date precedes January of '78, because that's when a very detailed work history begins. And so for all remaining observations, we're just counting up the number of weeks worked from the start date up to the interview week. A specific example can really highlight the measurement discrepancies. I've cherry-picked an example that's particularly dramatic. For this particular respondent, the first 4 times he was interviewed, he said at the time of the interview that he was currently enrolled. The 1983 interview was the first time where he said, "No, I'm not currently enrolled or attending school." That interview took place in January of '83. He was asked, "When were you last enrolled?" And he said, "Last month." So 1982 would be the ABH start year. His highest grade completed in May of '83 was 12. It was actually only 11 back in January, so they're giving him a boost. And it's going to increment all the way through 1987. So this guy can contribute 1 observation to the ABH S equal 12 sample. It would be the wage reported in 1983. He's been out of school for a month. They give him potential experience equal to 1 year. He can then contribute multiple observations to their S equal 16 sample, starting with the wage reported in 1987. And even though he's entering the world anew as a highly schooled worker, they're giving him 5 years of potential experience at that point. When we bring in the monthly enrollment timeline, we see that there's no break in his enrollment other than pretty much every July and August up through 1987. He leaves school permanently in May of '87. So our start date is June of '87. His highest grade completed at that point is 16. So we can have him contribute multiple observations to our S equals 16 sample, starting with the 1987 wage observation. He was interviewed in August, so we give him 2 months of experience at that point. So this is a case where their start date is much earlier than ours. Theirs was triggered by the shortest possible break from enrollment. It appears this guy is just home for the holidays, or he's out of high school for the holidays. We're both using the same 1987 wage observation, but they're assigning him 5 years of potential experience. We're assigning him 0.17 years. And it's because they're using time-varying schooling that they can have the same guy pop up in both samples. A very quick glance at variables in the wage model. I'm only going to report estimates for the ones that are marked in red. We don't have any particular interest in sample sizes, but just to be clear, we can think about their S = 12 sample and ours based on potential experience. Almost 11,000 observations are common to the two samples. So for those common observations, we're using the exact same log wage, it's the same calendar year, it's the same AFQT score, all the variables are identical except we're assigning different levels of potential experience. They have an additional 886 observations that wouldn't make it into our sample. It's before our start date, or it's after we have the guy going back to school, or we wouldn't have assigned the guy S = 12. And then we have 2,600 observations that don't make it into their sample. So we want to compare starting dates. To do this, we're going to aggregate hours up to the calendar year. In the upper right-hand panel, these are the observations for the S = 12 guys. These are the observations that appear in both samples. The start years are in agreement 92% of the time. When they're not, the ABH start date is almost always earlier than ours by an average of 1 1/3 years. And in the bottom right-hand panel, when we go to the S = 16 guys, the start years are in agreement only 2/3 of the time. And among the remaining observations, the average difference is about 1.8 years. And unsurprisingly, for the observations that don't even make it into our sample, there's far less agreement. The discrepancies in start dates translate into mirror image discrepancies in potential experience. So these are pretty much the same numbers. When we go to actual experience, there's much more agreement as expected. Upper right-hand corner, where we round the actual experience values to the nearest year. They're in agreement 96% of the time. And even among the S = 16 guys, they're in agreement 89% of the time. So for the regressions, in column 1, we're using their sample. It's their variables, so it's their experience measure. These are the exact numbers that they report in their paper, and it's obvious why they conclude that there's strong evidence of learning among the S = 12 guys. There's no evidence among the more highly schooled guys. In column 8, it's our sample, our measures, and we're obviously seeing comparable evidence of learning for the two types. And we just want to do a few experiments to see what exactly is driving these differences. In column 2, we stick with their sample, their experience measure. We simply drop observations that precede our start date. Column 3, we're going to drop observations that come after we have the guy going back to school. Across the board, the S = 12 estimates are robust to any and all experiments, but in the bottom row, the key parameter estimates are getting a little bit bigger, but we're certainly not reversing their conclusions. Column 4, we stick with their data. We're just going to drop observations where we would have assigned a different schooling level. So we're dropping a subset of the observations that make it into their sample but don't make it into ours. And then in column 5, we're just dropping all the observations that are in their sample but not ours. And in the bottom row, those point estimates are getting even bigger in magnitude, but we're still not quite reversing their findings. And then in column 6, we stick with their sample, their experience values, but now we're going to drop any observation where their start year precedes ours. So we're effectively dropping any observation where the two experience measures are significantly different from each other. And now, finally, in column 6, we have estimates that are very much like what we see in column 8. So hence our conclusion that the discrepancies are driven by the fact that they're overstating experience for the highly schooled guys. And then finally, in column 7, we go to our sample and our measures. but we get rid of any observations that aren't in their data, and we get numbers that are very much like what's in column 8, so we can rule out the notion that it's differences in sample selection that drive these discrepancies. Do it all over again using actual experience. I don't think these are, this is the right way to conduct this test for employer learning, but across the board you see that when you switch to actual experience, because the discrepancies between their levels of experience and ours are not as great, we're compressing any differences between their estimates and ours. And then finally, we're going to pool across schooling levels. So we're not just combining 12 and 16, we're bringing in observations for anybody with schooling between 8 and 20. And there are some minor differences between their estimates and ours, but across the board, there's very clear evidence of employer learning. So the point here is that the measurement problem is very much concentrated among the highly schooled guys. When you throw them in with everybody else, they're outnumbered. We're no longer identifying the parameters off of those mismeasured observations. So to conclude, I think it all just comes back to the notion that school-to-work transitions are messy, so the data aren't going to point us right to a t equals 0. That is just not a well-defined date. Like it or not, researchers have to find a start date that's appropriate for their purposes. I'm certainly not claiming that there's one right date or that we would be the ones to have it, but I would like to think that the definition we're using belongs to the class of sensible definitions. Within the learning literature, we found at least 3 papers where the authors are thinking about this and really trying to come up with a suitable start date. In that original paper by Farber and Gibbons, they have a start date based on a transition from being primarily not a worker to primarily a worker. Schoenberg does something along the same lines, and Pinkston is using the date of final school exit. These all seem perfectly sensible. The ABH definition, I think, is just not too terribly sensible under any conditions. Interestingly, they weren't the ones who thought this up. This particular definition was used by Altanji and Perret in their seminal paper, and it was then also used by Lang, and ABH reveal that they used Lang's Stata code as their starting point, so it appears they simply were going along with the gang. The estimates of Altanji and Perret and Lang are not sensitive to these kinds of measurement issues, but the reason why ABH sort of get into trouble is because they are not only starting the clock too early for the highly schooled guys and therefore systematically overstating experience for the highly schooled guys, but they, in contrast to anybody else, are identifying these learning parameters exclusively off the highly schooled guys, and that's, I think, quite clearly why they have this non-robustness. So the bottom line, I think, is that measurement matters, who knew, and sometimes it matters a whole lot.
I think I'm all set, and it's also a privilege to be here. And the one, it's fitting that I follow Audrey, since I followed her to UCLA and working with Finus. And one of the things that Finus, one of the areas he did a lot of work on, which was what Audrey worked on a lot, was school desegregation. And not only did he put a lot of his skill into it, but he put a lot of his own resources into it to make sure that as a country we had the information that we needed to know what was happening. And I appreciated that. And he also, I think, taught us that even if other people get very angry and insult you about what you might find, it doesn't matter, as long as it's true.
We'll see.
This is a careful and sharp empirical analysis. Obviously, in Finus's tradition, it's kind of a hard paper to discuss since it's a critique of another paper, and I think it's really well done. I think the one that I liked Audrey's showing of one observation today, and I think it would be nice to have a little table showing exactly how many observations at each schooling level fit in the category of this person was only off what appears to be for a short period, and then we're continuously in school afterwards. And I think that would be compelling. There's some additional questions that I had. ABH focused on statistical discrimination, differences by education. That was really, I think, the main thrust of their paper. And they argue that there's strong evidence of statistical discrimination against high school graduate black men, and little or no evidence of statistical discrimination against college graduate black men. In fact, that affirmative action at this time actually elevated their wages above that of white men. And I was wondering whether these conclusions also fail to hold up under close scrutiny. And in addition, is the discrepancy in findings driven by college graduates that take longer to complete college or work well in college? So it's an interesting thing that you find that how important the discrepancy is. The people who have the simple career history of school, stop, work, presumably ABH got them right. And it would be interesting to know if you just look at them, what are their results? I thought that some uncertainty remains over the measure of school attainment. An employer may or may not treat a high school student employee as a high school graduate in terms of career track. So someone who hires someone during their junior year of high school, when they think about their education level in terms of when they're hiring them, kind of like when we hire ABDs out of graduate school, they may actually think about that person as a high school graduate if they're doing well. We think of schooling as more of a signal. Same with a college student that begins work during the summer. And the measurement of schooling determines the attribution of the signal. Okay, so consider working college students that have a non-enrollment spell. Over time, employers might update their evaluation of skills based on the productivity on the job, and those with higher skills are more likely to graduate college. Alternatively, employers may have identified skilled college students very likely to graduate at the time of hiring based on performance to date in college. In the first case, employers do not classify the college student as a college graduate, but in the second case, they do. Now, Audrey and her co-author throw these students out. They don't use that short spell anyways, and any incrementing of education that's significant after a full year out of school is thrown out. So this isn't a problem for what they're doing, but I thought it was an interesting thing to think about. The method for assigning schooling level carries the assumptions about employer behavior. ABH assigns the highest grade completed, making a strong assumption about employer belief about employer schooling category. And LM recognizes the ambiguity and throws out the observations following the attainment of additional schooling because of the possibility of additional human capital accumulation. I thought it would be informative to examine wage growth in the current and subsequent jobs for those that increment schooling, kind of challenging the assumption that knowledge is public. The career start date is also complicated because the career begins for many while in school. This creates an ambiguity, and this paper provides a much clearer taxonomy. The taxonomy considers part-time work while enrolled in school as pre-career. And the ABH taxonomy also counts some part-time work while in school as pre-career, but it includes more such work as being part of the career. Some employer learning may take place during this period, and the implications should be explored. I thought it would be interesting to divide the sample by school timing and employment transitions. There's a lot of evidence that wage increases are concentrated during employment transitions. More highly skilled workers may receive more on-the-job training conditional on formal education. If higher skilled employees receive more on-the-job training in their initial job, is the subsequent employer paying for the skills obtained on the previous job or the more fundamental employee skills that led to the training? So you judge someone as having received this additional training experience. Is that evidence of the kind of person that they are, kind of fixed, or are you rewarding them for their skills? Analyze within job and between job wage growth separately. Compare the basic regressions with those that add an employer fixed effect and those that focus solely on transition-driven wage changes. Examine separately students that begin their post-enrollment job while still in school. The other thing I thought about was this idea of socio-emotional skills being important, that the NLSY has measures of this, and it will be interesting to see if there's learning of these skills as well. I know this is beyond the critique of the ABH paper. And I think it would be important to expand the conceptual discussion of the skill-related differences in wage trajectories. The paper takes as given the basic learning model. I think it would be helpful to elucidate the key assumptions. Can you take steps that enable you to relax assumptions about wage-setting behavior? There's very little in the way of reference to personnel economics or the possibilities of different wage gradients systematically related either to skill level or level of schooling. And I was also thinking, and Bob mentioned it during his talk, about education and production. And in that paper, you think about different types of skills that employees are bringing to the job. One is sort of technical skills of being able to do something, and the other one is skills of being able to allocate. And it may be that employers can learn very quickly about technical skills, and it takes a lot longer to learn whether somebody's good at allocating and working with information. And that might be another way to think about this problem. That's it.